let's take a look at the answers to these examples. In the first example, the cation is potassium, so we just name it as potassium. In the brackets is the coordination complex ion. PT is platinum, but since it's part of the anion, we must rename it platinate. There is one ethylene group, so we don't put mono, we just put ethylene in parentheses, and 3 chloros, trichloro. Now, since you have one potassium, which has a 1+ charge, and each chloro has a 3- charge, that means platinum must have a 2+ charge. And we include that at the end as a Roman numeral. The name for this compound is potassium trichloroethylene platinate 2. In the second example, we have a complex cation and a complex anion. In the complex cation, we have palladium that is coordinated to 4 amine groups. 4 is tetra, amine, palladium. In the second compound, or second part of this compound, the anion, we have palladium again coordinated to 4 chlorines. That would be tetrachloropalladate because it's part of the anion. The easiest way to determine the charges on the 2 palladiums is to say, what is the only way I can get one palladium cation and one palladium containing anion to come together? And that's if you have palladium 2+ for both of them. In the third example, we have cobalt. But this is a neutral coordination compound without an anion. Cobalt with 3 amines and 3 nitro groups. Amine comes before nitro, so we name this triamine trinitro-cobalt 3. You also have to try to name the compound or write the formulas for the compounds in the other way. What is the chemical formula for the following compounds from the name? Try these on your own, then check your answers afterwards. Let's take a look at how we would write each of these as chemical formulas. For the first example, pentaamine, that means there's 5 NH3s. Dinitrogen, now this is a ligand, not two nitrogen atoms. So this is N2, ruthenium, Ru. Since amine and dinitrogen are neutral ligands, the cation has a charge of +2. That means 2 Cl- should act as the counter ions to this complex cation. In the second example, we have hexaamine. That's 6 NH3s bonded to a cobalt, as shown in the first part. Pentachloro, that means 5 chloro groups bonded to cuprate, that's copper. CuCl5. Copper, its most common oxidation state is +2. If copper is +2 and Cl5 has an overall 5- charge, that means the complex anion must have a charge of +3. Therefore, to balance the -3 charge on the anion, cobalt must have a +3 charge. The third example is diamine dichloroplatinum 2. Platinum is the metal, Pt. It has two amine groups, so NH3, 2, and two chloro groups, Cl2, and it's a neutral compound. So it is Pt, NH3, 2, Cl2. Now remember that the definition of ligand is a simple or complex ion or molecule that bonds to a metal center. We're going to introduce some new nomenclature for you to consider as you think about ligands. One is monodentate. It comes from the Latin mono meaning one, dentate meaning tooth. That means that one of the atoms on the ligand that has the electron lone pair can bond to the copper 2+ cation. The ligand can only bond one time to the metal cation. Bidentate means two teeth. So the ligand must have two atoms that can bond to the metal cation. Here I'm showing ethylene diamine, which can take and form two bonds through the nitrogens to copper 2+. Coordination number is the number of ligands or the number of atoms from ligands bonded to the metal center. Let's think about coordination number in just a minute. The coordination sphere is another definition you need to know. It's a collection of ligands around the metal atom or ion. Ligands that coordinate to the metal center are included in brackets with the metal when writing the formula. So the ligands that bond to CO and satisfy the secondary valence are the 6 NH3 ligands. The counterions, 3 Cl-, satisfy the primary valence and are outside of the brackets. There is more terminology that you need to know. Chelating agent. A chelating agent is a ligand with more than one atom that bonds to the central metal atom. Chelate has this word chel, its root, which means claw. So like a lobster or a crab that has two claws, the two nitrogen atoms on ethylene diamine can grab a hold of the copper cation. Coordination compounds that contain chelating agents are known as chelates.